Hi, everybody. My name is Sama. I hope everyone is hearing me. So thank you for participating today to this webinar organized together with the Iceland Renewable Energy Cluster with Rosa. So just in one slide, I would like to present briefly Cluster Tweed. So it's a non-profit organization that has been created 15 years ago. And it aims at gathering all actors working in the renewable energy sector. And today, Tweed counts more than 200 members from the industrial, public, and academic domain. And in fact, Tweed consists on two distinct clusters, like you can see. So first, Tweed focused on the energy topic, and H2O focused on all topics related to water. But of course, there are often projects related to both energy and water. So within Tweed, there are several ecosystems. And the first one was Seracle, related to energy community. And this ecosystem was created 4 years ago because there was a growing interest for energy community and more actors were active in this domain. And Tweed felt a need to support the sector and to help developing an appropriate legal frame from energy community. And that's why a specific ecosystem was built up. And same occurred for hydrogen with H2Hub. And now we observe a similar trend for district heating and geothermal projects in Wallonia. And there are quite a lot of incentives and regulatory disposition that came up in Wallonia. And we thought, okay, this is the momentum to launch a new ecosystem for green heat. And this ecosystem is called Heat2Net, and it aims at gathering actors, and hopefully it will help information exchange and facilitate interface with the stakeholders. And Tweed wants to play a role of animation within these clusters, and we'll try to propose actions related to cluster service. And you have all these services in this figure. So we are active in networking, mapping, knowledge sharing, support for innovation, and partnership development. And you I guess understood. That's in this context that we have organized together with the Iceland Renewable Energy Cluster this webinar about geothermal project and district heating. And because we all know the big challenges regarding this sector and the need and obligations of decarbonizing heating consumption. Of course, Iceland has a huge potential for geothermal energy, and Iceland is clearly a step forward. And the goal of this seminar is to benefit from experience of Iceland actors, and so that we can more easily and faster handle this topic in Wallonia. So before listening to Icelandic actors, and I would like to thank them for being here, I will let Nicola Vanek explaining the context in Wallonia. So thank you, Nicola, for accepting this mission, I would say. So Nicola is working for Resolia, that is a company expert in thermal network engineering. And Resolia has been designed by the Walloon administration as technical and legal expert in the field. If you have questions, I would like to invite you to use the chat box to write down your questions, and we will handle them at the end of all presentations. And so you have heard that the presentation is, the webinar is recorded. You will have access to the records and also to all presentation afterwards. So Nicola, you can now share your screen, please.
Hi, everyone. Louise, maybe you can confirm that you can see the screen.
Yes, it's okay for me, and I can hear you.
Okay, perfectly. Perfectly well. Thank you. Thank you, Louise. Thank you to the cluster tweets for the invite. You have already summarized indeed what Resolia is. So we're in startup active in decarbonation of the heat through different type of work that we do, mainly in district heating and geothermal spheres, I would say. So I've been requested to by Cluster 3 to give an overview of the geothermal context in Wallonia, Belgium, and also to identify the needs to develop geothermy and district heating in the region. So that's what I have done through those approximately 10 or 12 slides. Let's start directly. So just to give a bit of an introduction first, the Belgian context is a bit particular compared to maybe to what you have in Iceland. The competencies such as environment, urban planning, economy, etc., are regionalized, and we have 3 different regions: Flanders, Brussels, and Wallonia. So that makes we have lots of different rules, lots of different ministers, and that's sometimes complexify things and make things a bit more difficult. But I think we're doing quite a good job so far, so it's quite good. I have also put a very old map of the geological context of the country, and you can see a very different context across the 2 main regions, which makes the geothermal reality quite different in Flanders than in Wallonia. If we continue on the Belgian context and especially on the Wallonia objectives, so the Repower EU plan from Europe has been translated into a plan in Wallonia, which is the Plan Air Climat Énergie, with a very ambitious objectives for 2030. For example, times 6 in terms of development of heat pumps into the region. So let's divide the presentation into 3 main parts. The first one is dedicated to deep geothermal. To give a status on deep geothermal in the country, well, that map synthesizes, I think, pretty well the context of deep geothermal in the country. So we have actually one location in Wallonia where we have 3 deep wells, maximum depth of 5.2 kilometers, but productive around 1.5 and 2 kilometers deep. It's only for heating. They are connected to a 4 kilometers district heating, and they're currently used for heating public buildings, 1 pool, 1 gym, schools, etc. You can see a very simplified log here on the side. And then there are two other locations in Flanders. Another one which is public, the Mol Balmat well, which is productive at 3.6 kilometers, and another one that has been opened very recently by Janssen & Janssen, so it's part of the Johnson Group pharmaceutical company, which recently opened a 2.4 kilometers deep well in order to heat their big campus in Beerse. The potential is proven in Wallonia for deep geothermal, especially on the red and orange zone that you can see on the map here. The yellow and the green areas are potential to be determined reserves, I would say. There is an upcoming project coming, a geophysical public tendering that was just out a couple of weeks ago for detailed exploration on 4 large areas in Wallonia. That is ongoing until 2025, and that will help to better understand the reality of the deep geothermal context in Wallonia. If we go to the second part, which is the shallow geothermal status in the region, this map summarizes the active and the inactive shallow geothermal systems in the region. you can see that in terms of closed-loop system, we have about 2,000 systems installed, mainly residential ones, private residential installation, and that we are currently going around 150 to 200 installation per year. Again, mainly private residential installation. In terms of open loop system, we have only one existing project which with an aquifer re-injection. And there are at the moment approximately 20 projects that are under study in the region. If we look at the open loop systems with surface reinjection, so in surface reinjection, we have about 40 existing projects at the moment. And then we also have 2 projects under study for mining geothermal. If we look at the available maps for potential for shallow geothermal status, we can see basically that the entire region has a pretty good potential in terms of shallow geothermal, both in terms of closed loop than in open loop. I have also provided some maps that Resolia and Bruxelles Environnement, so the Environment Regional Association for Brussels region have worked on. You can see on the left-hand side a map of the potential for the closed loop geothermal across the region. And also, I must say that they have a very good system that can be used by everyone. It's a freeware. It's accessible on the website. On the right-hand side of the slide, you can basically type a location on a GIS map on their website, and the website provides you with the potential in terms of shallow geothermal for closed loop or open loop system, with a very simplified but very accurate view through geological logs and layers of what you can find in the subsoil. What about the upcoming projects for shallow geothermal? Well, this map summarizes that for Wallonia. Recently, that was last year in 2022, about 34 projects have been awarded by the Walloon region to really support the development of the shallow geothermal projects in the region. There are 24 private projects and 10 public projects that have been selected. There are also support from the FEDER, so from the Europe. There is also the Interreg project, which helps to better understand shallow geothermal potential. There are some incentives in terms of feasibility studies. And I must say that since a couple of months, or maybe 1 year, we can see a very nice a boom in the private sector, which starts to invest massively into the shallow geothermal for real estate, industrial, or commercial development. And we can also see a boom in terms of closed loop system installation for private residential. Still quite expensive, but we can see a boom in terms of installation. The third part of the presentation is about district heating status. This is a map we quite like at Resolia because it's summarized based on the Euroheat and Power 2017 data. So it's slightly old, but it gives a good feeling of what's happening in Europe in terms of district heating development. And we can see actually that Belgium is absent of the European map, because it's less than 0.05% of the heat needs in the country that are covered by district heating. While you can see, of course, the Eastern Europe and the Northern Europe countries who have a very good ratio of district heating installation. And especially for the Northern Europe, of course, Iceland, a nice percentage of renewables that are being used for those district heating. If we close loop to Wallonia, This is a map that summarizes the district heating installation in the region. You can see that it's pretty nicely spread across the region. Majority of those installations are actually small public district heating, which are gas or biomass sourced at the moment. And in terms of upcoming projects, there is at the moment a new call for public tendering that is supposed to provide 30 million euro of public funded money for decarbonized district heating installation in the region before 2026. There are also FEDER, so Europe public tender, and I must say that we also see some requests from the private sector to start to invest massively into the district heating mainly for real estate and commercial development. The last part of the presentation is about the growth opportunities and how to move forward into the geothermal and district heating sectors. This is a post-it note that we have done at Resolia, a very quick calculation we have made. If we consider 200% growth per year, which is quite big already, we would arrive at 2030 with about 200 machines and 400 operators for about 1,000 employment. And that's only to answer about 1% of the total energy consumption in Wallonia. So that gives a good feeling of the investment that are needed for the geothermal development into the region. And then the last slide is to us at Resolia, what do we see as an important step to move forward on the geothermal and district heating agenda? It's divided into 3 pieces. First, in terms of people, staff, we need to increase the professional training to promote this job and to help having more staff working into that sector. We need methodology, so we need to work on code of good practice and technical guidelines for geothermal. And we need to structure and create an industry and group together all consultants, architects, drillers, drilling companies, etc., all together. In terms of money, we need to continue the financial support the Walloon region is offering since 2 or 3 years, and call for public tendering, incentives, etc., are very good, and we need to continue that. We need to work on the risk management, for example, through a public funded guarantee mechanism to help investment. Indirect financial support is also good in terms of support on the VAT for heat. And of course, investment, public investment in massive projects. And deep geothermal requires massive investment from the public to help structuring the deep geothermal sector. And then the last one, in terms of tools, I think we need to decrease the admin burden related to some permitting procedures. It would be good to have a centralized district geothermal decision support system. We need to have more maps, more data onto GIS, database reporting. Digital twins is also very important to understand where the heat needs are. And we need to increase the communication and marketing. Final slides. At Resolia, we see the district heating and geothermal as speaking together. One will develop if the other one develops as well, and that's what actually is written in the report from Aalborg University in November 2023. 20% of district heating to unlock the long-term potential. It's really the missing link in the REPower EU legislation. Thank you.
Thank you, Nicolas. Very interesting presentation. If you have questions, don't hesitate to write them down in the chat box. And now I will let Rosa present the Iceland Energy Cluster. Rosa, can you take over the screen sharing?
Yes, hello everyone. And now I would like to do sharing my screen here. Everybody seeing it? Seeing my screen?
Yes. At least I
Great.
see your screen.
Yeah, that's great. That's great. I hope everyone. Hello everyone. It's such a great to be here with you today on the screen, and we are taking a step forward since we started our collaboration and coordination and conversation, and that is what the cluster do. My name is Rósbjörg Jónsdóttir, or called Rosa, which is much easier to pronounce, and I am the managing director of the Iceland Renewable Energy Cluster. Today, I would like to share with you the main issues about the geothermal in Iceland, as well about the origin of our cluster existence. And along with me are selected expertise who will share with you the importance of this energy resource, as well giving you the idea how and what can be done and where, because they have a great experience from all around the world. Having said that, it is good to start the importance of the geothermal in Iceland. Iceland is situated between the European and the North American geological plates in the northern region. Thrives due to its accessibility to renewable energy sources. And without this advantage, probably the life here would unquestionably pose some challenges. With approximately 85% of the Iceland's primary energy needs, we are meeting it with renewable sources, while our households' heating exclusively relies on those sustainable resources. Geothermal energy stands as one of Iceland's cornerstone assets, significantly enhancing our quality of life and fostering economic growth. By leveraging geothermal resources for household heating dates back to the early 20th century. But this shift brought about substantial improvements in public health and accelerated economic development, positioning Iceland as one of the world's most advanced nations. Over the decades, we have also harnessed geothermal not only for heating, but also for the electricity production. And we have accumulated expertise and experience, enabling it to utilize these resources sustainably. The fortunate acquisition of the specialized knowledge has followed us to extensively leverage geothermal energy for various purposes. We are ensuring maximum utilization and sustainable practices. Our utilization spans across diverse sectors, which helps improvement of the community. Along with the electricity generation and district heating system, we have been greenhouse cultivation, aquaculture for fish farming, algae production, cosmetic manufacturing, food supplements, and preservations, as to mention only a few. We, by utilizing high temperature resources, cascading down to low temperature applications, has been a significant contributor to our economy. And moreover, our experts have actively supported and developed numerous geothermal projects worldwide, applying this Icelandic approach, and which you will learn later on. Talking about the cluster itself, it actually, we think back to 2006 when we had the Harvard business professor Michael Porter evaluating the competitiveness of our nation. And he pointed out that due to our exceptional expertise and knowledge in geothermal and how we have been capturing geothermal energy, for the society. This was some advantage we should take very good care of. And that was the start of the first map, which was evaluated on a conference 2010. And then the industry started to work together, and it was formally founded as a legal organization 2013, focusing on the Iceland geothermal, and was called the Iceland Geothermal Cluster. In 2018, it was expanded into the energy cluster or renewable energy cluster, expanded to the hydropower, wind power, and power to X as well, along with the geothermal, looking into all resources which are of potential here in Iceland. Today, we are focusing on a responsible utilization of our resources through our values and trying to maximize the outcome and be a strong actor towards the challenges all the nations are facing today. The Iceland Renewable Energy Cluster, it's a private-driven cluster organization which is serving the whole energy sector in Iceland. We are a non-profit organization with over 50 members, covering from the whole value chain, from scratch to end users. And all those have in common to improve its role and have impact on its society. As mentioned before, our members have a very strong and exceptional experience around the globe and have been involved or leading big projects all around. And it will be a very interesting for you to listen to some of my strongest members sharing their knowledge. But having listened to your information about your region, it is important that we can look at where we can work together. Here is the map of our cluster, the geothermal cluster, and you mentioned several points like training and knowledge, methodology, structure, the industry and financial issues. I'm definitely sure that we can do something together in that field, because clusters are bridge builders. We are working on this is a very important step which we are looking into. Our focus is on collaboration, knowledge sharing, and development. And we set up different actions towards improvements like innovation and progresses, where we are focusing on workshops, analyzing and assessments. We work on a project for internationalization and cooperation, like we are doing here today, like Cluster to Clusters, participating in grants and symposium, workshops and webinars. And last but not least, we are focusing on education and training. And then we are one of our key action is the international conference, Iceland Geothermal Conference, which is actually the origin of our identity. And we are really proud that we are sure that this could be the next step of our collaboration. Our fifth Iceland Geothermal Conference will be held here in May 2004, where we will focus on the importance of the geothermal globally, with the headline "Redefine Tomorrow with Geothermal," and looking into issues like security and stability, opportunity and innovation, viability and productivity. And these are very important issues, and combined to the highlights of it, we will dive into discussions about how geothermal is the vital tool to ensure climate resilience. We will explore the innovative frontiers of geothermal technology and research. We will uncover the economic viability and profitability of the geothermal ventures. Geothermal is more than just energy, it's a catalyst for change. So we will look into these important issues of sustainable society of building. And last but not least, the geothermal is all for everyone, and it can have no boundaries. So we will have that. And it is a fantastic opportunity for you to learn and train and maximize your way of moving forward. We are promising an extensive agenda with international speakers from all around the world, based on and the showcase is Iceland. So you can be learning by experiencing how everything can be done from the low to the high heat productions. We will have a very impressive business showcase exhibition where you will be able to meet with key international players. Participants will have a multiple choices of participating in field trips, both local within the city, as well out going out to the fields where they are grabbing the energy. And last but not least, we will operate in a matchmaking program for with business to business meetings, where you can have individual meetings with this expertise. And all these kinds of actions are great networking, will be built with great networking opportunities for everyone. So we think that this is a way forward in our process, and I cannot be bored with the words from Henry Ford that we have already been together, and that is the beginning, and now we are staying together to building up the progress. And let's start when you have learned about my experience, the experience from my members later on. I'm definitely sure that we can be working together with in a successful way. But last but not least, we need to participate, ensure that everyone are involved in the value chain. Having said that, I think that you have some overview of how we are working, what we stand for, and it is a time to move a little bit forward and learn about the first step, which we need to keep in mind when we are moving forward into geothermal projects, and that is the legal framework and the licenses. So I think that I would like to introduce the first Icelandic speakers, which is actually not originally Icelandic. He can speak French, but I will not understand him then. But it's a great pleasure to welcome Anton Lucet on the screen, who is the consul by the legal company BBA Fjellco, who have a very exceptional successful story in the field of setting up the energy project worldwide, and have helping different both private bodies and public bodies to capture and implement energy productions. Anton, over to you.
Thank you, Rosa, for the nice presentation and the introduction. I hope everybody can hear me correctly. Great. So my name is Antoine Lochet, and I'm a lawyer, and I work for the Icelandic law firm BBA Fjellco. So BBA Fjellco is a corporate law firm. We are a full-service law firm. And we also we are very active also in the field of energy law, and we created a separate entity, a separate department called Elements by BBA Fjellco, where we deal with all the energy law related matters. So we work for developers, so private entities, but we also work as part of our missions. We work for governments, mainly through the World Bank. So we advise the World Bank and the United Nations, so the development program of the United Nations. We advise several governments on how to develop their legislation in order to attract geothermal investment. So here, this presentation today is going to be about, well, our experience in that field. Next slide, please. Thank you. So the title of the presentation is Enabling Legal Framework. in the geothermal sector. So what do we mean by enabling legal framework? Well, it's a legal framework that first is designed to attract investment. So investors most of the time have due diligence on the country in which they want to invest, and they have a close look at the legal framework. Amongst others, the permitting procedures, but also the institutional matters and investment laws as well. So that's one of the key aspects that need to be dealt with in the legislation. And then on the resource, the framework needs to provide for the mechanisms to adequately protect the resource and manage the resource. So it deals with water legislation, for example, and environmental legislation. Then the legislation needs to take into account the technical specificities of geothermal resource. As you know, the geothermal resource is a special one. It's tempting to compare it to mining resource or any other type of underground resources, which is maybe correct to a certain extent, but not entirely. So the legal framework needs also to take into account those specificities. And then legal framework should also contain provisions on or provide mechanisms to facilitate social acceptance, because social acceptance in most of the countries we've been involved, social acceptance is one of the main risks to be addressed by the developer for several reasons. And the most interesting part of it is that it's not necessarily the same reasons depending on the country. So next slide, please. So here you will see, well, the main aspects that have to be, that we think and that we came to the conclusion that have to be dealt with in a legal framework. So I'm not going to go deeply into all of them. I will address just a couple of them in the presentation, but I have also a few words to say about some other issues. So the first one, the definition of the resource. So the resource, the geothermal resource, has to be defined in legal terms, because the definition of the resource will decide on the regulatory framework that applies to the resource. So for example, we might want to address the questions of depth, temperature, thermal potential. And depending on those criteria, various legal frameworks or regime will apply. Then the question of ownership of resources. In most of the countries we've been involved, the resource, the geothermal resource, at least the deepest ones, are in the ownership of the state. There are a couple of countries that provide for private ownership, or at least that the resource are owned by the owner of the surface. And interestingly enough, Iceland is still one of them. Then you have questions of environmental obligations, social acceptance, which I would say a few words about later on. The most important aspects I wanted to touch upon here is the licensing procedure. Nicola already mentioned it, that the licensing procedures need to be streamlined, and that's something that we put a lot of emphasis on. That licensing procedure should be a special one, not necessarily the licensing procedure that applies to mining. It needs to take into account specificities in terms of technical competencies, financing of the projects as well. In terms of institutional aspects, having simplified institutional framework also helps in attracting investments and developing projects. Ideally, creating a one-stop shop, so only one institution that would be the contact point for the developers. We know that in many countries it's not possible because there are already several entities that would be competing. and would be competent for geothermal projects, but to the extent possible, try to streamline the institutional framework. Then I will say a few words about cascaded use of resources in a few moments. Last but not least is the incentives and mainly the risk sharing. Risk sharing or risk mitigation is a key aspect of the legal framework. It helps to attract investments. So the idea is to de-risk exploration, de-risk utilization, and to provide the developers with a satisfactory mechanism to mitigate those risks. Next slide, Rosa, please. So three aspects will be more specific on is the importance of a state policy, the notion of cascaded use of resources, which is mainly relevant in case of direct use of the resource, and a few words on environmental issues and social acceptance. Next slide, please. So, and next slide again. So the importance of the state policy. So in most of the countries we worked, we've seen that the most successful countries are those that have developed a national policy that take into account both the short-term and the long-term goals, that establish meaningful policies, that enable an understanding of the country's potential resources and the chances of failure of or success of existing projects. Also, the national policy should aim to create what we would call a geothermal atlas, so gathering data and information on the resources that would be made available to the developers in order to minimize the risks as well. Next slide. A word on cascaded use of resources, and we will see on the next slide Icelandic example of what we call cascaded use. Rosa, you can move to the next slide. So here is a map of what we call the resource park. So there are two maps here on the presentation. So just to make it short, the resource park is an area in the southwest of Iceland, not too far from the Reykjavik area, where we find a power plant, or actually two power plants, geothermal power plants. But the idea of the resource park is to use, well, the waste, in quotation mark, of those geothermal plants, being residual heat in the form of water, but in the form of steam as well, and to develop businesses all around the power plants using the remaining heat after power has been produced. Well, power and also hot water for the district heating. So here we see the famous Blue Lagoon that uses hot water from the plant. We have Carbon Recycling International that uses the CO2, well, the few emissions of CO2 in order to produce methanol. On the next slide, we will see more agriculture and fish farming industries using the heat to dry fish, to grow vegetables, just to name a few. So that's an example of cascaded use. But we will see on the next slide that the legal framework needs also to facilitate those projects, because in countries that will mainly rely or use the resource for direct use, so heat production, cascaded use could also be a solution to enhance the value of the resource. So to find several offtake options in order to make, for example, a project more bankable. So the legislation needs to allow for multiple licenses on one resource. The framework needs to clearly define the activities under the licenses, because, for example, in some countries we've seen that The only use of geothermal resources that is allowed is power generation, which is an obstacle to, for example, direct use for district or heating or cooling. So it's important that the legal framework provides for multiple uses of the resource. When the resource contains minerals, it's also important that the framework, the legislation, allow the extraction of byproducts such as minerals and CO2, as we've seen in the resource part. Also, the shared liability of users, because we will have multiple users on one resource. They will collectively utilize the resource. They will collectively have an impact on the resource. And legally speaking, there needs to be an allocation of liabilities between the users. And that's something that has to be dealt with either in the legislation or in the contract arrangements between the users. And then also the question of ownership, and not only ownership, but the right of use of the resource, because we've seen that ownership is usually clearly defined in the law, but then it's not necessarily the owner that will be the user of the resource. So the law needs also to create some kind of right of use on the resource. Usually you would find that in the water laws, for example, but most of the time that would not be sufficient or not really be adapted to geothermal utilization. Next slide, Rosa, please. Thank you. And just to finish with this presentation, a few words on environmental and social issues. And so basically the four main aspects on those issues that have to be dealt with and are most of the time already dealt with in the legislative frameworks are environmental impact assessment. So depending on the countries, geothermal projects, so either exploration or utilization, would be categorized differently in the classification of infrastructure that necessitate either a notice or a full impact assessment. The social impact and the impact on local communities needs also to be addressed, because there needs to be a framework to consult, for example, the public and its local communities, so municipalities, for example, but in other countries it could be communities. So there needs to be mechanism to consult before the start of a project in order to ensure that there is social acceptance. I've already mentioned sharing and allocation of environmental liability in the cascaded use. And then there's the question of waste management. So waste management can be quite various. I mentioned the CO2. There's the question of re-injecting water. So we're not really talking about waste management here, but the question of re-injections also has to be clearly dealt with in the legal framework, because water laws maybe have an approach of re-injection, which is maybe not appropriate for geothermal utilization. So that's something also to pay attention to. And then taking again an Icelandic example on environmental aspects and resource protection. So Iceland has a quite interesting mechanism which it shares with other Nordic countries, for example, Norway. It's what we call the master plan for nature protection and energy utilization. So the goal of the master plan is to reconcile the often competing interests of nature conservation and energy utilization. And it's made on a national scale, and it's designed to occur at the earliest planning stages. So the idea is to identify what we call energy utilization options. So we're talking here about your resources in hydro, for hydropower, for geothermal power, but also recently for wind power. Iceland is not far ahead in wind power, but they are looking into it, and wind power would be also included in the plan, the master plan. So the idea is to identify those options and to classify them into 3 categories: either utilization, so the resource may be utilized; on hold, so it's some kind of waiting list to be classified later either as utilization or protection; and then areas, so resources that are protected. So one of the ideas behind this is to enable public consultation ahead, so before the project starts, and it's a national public consultation. It's not only for the affected local communities, but it's for the whole country. So there are 2 to 3 rounds of public consultations, and at the end there is a recommendation by the parliament. So it works in rounds. So a round could take several years, and it takes several years. And at the end of each round, there is a list, a final list of the resources classified between those 3 categories I just mentioned. Next slide, Rosa. I think that was my last slide. Thank you very much for your attention. I hope you find it interesting and helpful, and I'm open for questions when we open the Q&A session. Thank you very much.
Thank you so much, Antoine. It was a really impressive and a very important overview, and what we need to think of when we are starting to create a project and working with geothermal. But then it is my pleasure to move forward to introduce you to our next Icelandic speakers. That's the Eiríkur Bragason. He is the Chief Operating Officer of Arctic Green. Arctic Green is one of our leading energy producer developer in the geothermal field, and he will tell us the story about what they have been doing globally specifically and share their experience. Eiríkur, over to you.
Yes, hello everybody. My name is Eiríkur Bragason. I'm the Chief Operating Officer of Arctic Green. Arctic Green was founded in Iceland in the year 2007 with the goal of developing geothermal projects abroad, so not in Iceland. And so we have been working on projects abroad since 2007. And in the beginning, we started in China in cooperation with a state-owned energy company, Sinopec. Started to build up the first heating plants in cooperation with them. And there is both demand, and there are the resources, and everything is there what is needed to build up heating plants. And to make a long story short, then the heating plants are now 700 heating plants in China that we have been building up in cooperation with Sinopec. So we have been investing and funding half of this project. The other half is funded by the Sinopec, the Chinese company. And this is now producing close to 6.5 gigawatt of clean energy, mainly for house heating. So we are very proud of this project. It has a substantial impact on the environment, saving 60 million tons since 2007, and is still growing. It's still growing exponentially. So it looks very good. 2 years ago, though, then Arctic Green was joined by another investor that today owns 40%. That is the investment fund of Singapore, GIC, and they are bringing into the company capital for developing new areas, and our main focus has been on developing projects in Central Europe. Central Europe because there is great demand there for clean energy, for reducing pollution, being energy independent, lowering cost of household heating, and there are many other benefits of using geothermal. So we have been focusing therefore very much on Central Europe, and what is also important is that in many European countries, especially in the eastern part of Europe, there is access to heating grids. The heating grids are connected to the houses, and so we only have to produce heat, connect to the grid, and then we can replace coal heating or gas heating or oil heating. So just as an example, in Poland, there are 500 heating grids in operation, and most of them are heated with coal and gas. So some to a very minor part are heated with waste heat, but this is what we see as a great opportunity to have influence on the environment and make Poland more independent and energy-wise, and lowering household heating cost. So we have therefore started up a row of projects in Poland, 4 projects that we are working on, and 1 acquisition target that we are also working on. And we are then, in addition, analyzing approximately 8 further projects in Poland. So in Hungary, we have also been very active. We have a contract with the city of Budapest, the energy company of Budapest, and we intend to build up heating plants in Budapest and connect to the existing grid and provide Budapest city with clean geothermal heating. So we are starting with a heating plant that has a capacity of approximately 20 megawatts, but after that we will roll out a number of heating plants with the goal of heating close to 200 megawatts of thermal heating, which is approximately the base load of the city. So in winter time it has to be boosted with heat pumps. But the base load is 200 megawatts, and that is what we are aiming for to provide to the city of Budapest. So this is from a technical point of view relatively challenging because the heating grid in Budapest is operating on a very high temperature. And the resource in Budapest is close to 70-80 degrees. But in good cooperation with the utility company of Budapest, we have managed to find a solution where we stepwise increase the ratio of clean energy, and parallelly the utility company is changing and investing in their grid. So with the goal of replacing completely gas heating and oil heating in some time. So this is a very promising project, and we hope that we can work on further cities in Europe. We are In Hungary specifically, we are also working on 2 power plant projects in Hungary, where we intend to produce electricity and sell to the grid. The resources in Hungary allow us to do that. So the temperature in some areas is close to 125 degrees Celsius, and that is sufficient for producing power. In Slovakia, we are also starting up a new joint venture 1st of January with the goal of providing some industry parks and some cities in Slovakia with heating and partly with power. And in Croatia, we are also working on a number of projects in many cities in Croatia, approximately 7 cities. And in Germany, we are negotiating with some cities on providing them with hot water. So this was to give you a quick summary of Arctic Green. As stated here in this conference, then you will have access to the slides afterwards. So you can go through it if you are interested in further details. So what is important is that Arctic Green is an investor. We invest and fund our projects. We also bring to the table a number of specialists that are working with us. Some of them have been working with us for decades. That is not only the lawyers, Bibia Fjellko, who was speaking here before me, but also we have access to 700 engineers and geologists in the engineering offices here close to us that we have been working with for decades. And we are also pretty experienced in the business development, building up side businesses and making the business plan really work. Sometimes heating is not enough, and sometimes you need to have some additional revenues for making the project profitable. And this is also something that we bring to the table. So in terms of Belgium, then it's very interesting to hear what you are doing in Belgium, and obviously you are using shallow geothermal quite frequently. If I heard correctly, 2,000 heat pumps, and that's pretty good. But I believe there is an opportunity in deep geothermal in Belgium, and we would be very interested to look at that with you guys. So we could take a separate session on if there is some basis for cooperation in developing deep geothermal in Belgium. I believe Rosa will be able to give you our contacts for setting up a separate meeting on potential cooperation in Belgium. So, but one more time, the slides will be available after the presentation, especially those technical slides on Budapest. They need a little bit of time to look at them. This is a heating. This is a wellhead house in the city of Reykjavik. So we emphasize integrating this into the landscape. Our management has great experience in building up power plants and side businesses. Blue Lagoon obviously being the most famous one. In the meantime, producing more revenues and more valuable than the power plant itself. You might have heard the story that this was originally waste water from the power plant, but is now a very blooming business. So having said that, then I thank you very much for giving us the opportunity to introduce ourselves. There will be this geothermal conference in Iceland next year. Hopefully we will see you guys there also. But in the meantime, then Rosa will for sure be able to give you our contacts. Thank you very much.
Thank you so much, Eiríkur, for a great overview and great information about your impressive company After Green. We'll definitely keep that forward. Then, last but not least, I'm really pleased to introduce our next speaker, Karine Chatney. Are you there?
Yes, I'm here.
Yeah.
Do you mind having me sharing my screen, Rosa? Because I made just a few amendments since yesterday.
Yes,
you need to stop sharing if I'm able to share it.
Yeah.
Thanks. I will share what you're doing.
Okay. Okay. Karine is one of our board members as well, and she is the marketing director and engineer from the Verkis consulting company, who have been really successful around the world. And it will be impressive to hear and see what she has to share with us. Now you are sharing your notes slides, Karine.
Oh, wrong one.
Yeah, the wrong screen.
Here you are. I thought I was sharing the right one. Let me just share again. Of course, I know you wanted to do it that way so that we don't have any trouble.
Exactly. Just put it on a slide view.
Sharing. Yeah.
Put it on a slideshow, and then you have it.
Yes. Here you are. So okay now?
Yes, this is great. Here
Thank
you are.
you.
You're welcome.
So thanks a lot for inviting me to this webinar. My name is Karine Chatney. I'm also French, but I've been in Iceland for so many years, I don't remember. I'm marketing manager at Verkis Consulting Engineers. And just to give you a few words about who we are. We are actually the oldest consulting engineers company in Iceland. We had a 90-year anniversary last year. And as you can imagine, we've been involved in all the development of geothermal projects in Iceland since it started in the 30s. So we know a lot of things about geothermal district heating and geothermal power and overutilization. And here you have this beautiful power plant, the one that feeds wastewater to the Blue Lagoon. Today, or yesterday evening, we had an eruption just right by the power plant. And I'm supposed to talk about operation and management. And one of our big challenges these days at Verkis is just helping the power company and the district heating company protect their infrastructure and develop plan Bs so that they can keep their operation, although we have an eruption a few kilometers away. That's one of the big things. But we do other things. We help people from the very onset of the projects. And I want to touch a few, or just give you a few words about what is the development of geothermal project and why is it so special. A few examples of operation and management issues. I understand it might not be all relevant to your context in Wallonia, but some of them can be very interesting actually. How operation and maintenance management can be planned, and a few ideas on contracts related to that. So development of geothermal projects. Don't forget about one thing that's very important when you plan for your geothermal project, is that you can have many types of utilization, many applications that are relevant for geothermal. Not only power, basically we say it's feasible when temperature is above 150 degrees. Some people go lower, but also related to heat for district heating, of course, but other application. I will show you a few cases afterwards. Byproducts like Eiríkur was mentioning, and also Antoine before, There are many other things related to geothermal and mineral extraction as well. Think about it when you do your project, because these things can definitely make your business case work. I wanted to mention that we at Verkis have been involved in a few projects in Belgium. A few years ago, we provided consultancy to Vito in the Balmat project. I'm glad to see that it's up and running today. And also to the BRC, I'm not sure I'm pronouncing it right, in Janssen and Janssen Pharmaceutical. And I'm glad to see also that it's running today. It's really good to see. I understand that in Belgium and in Wallonia, you might have more cases here with heat or eventually byproducts. Power could be a case in some cases, but my presentation will be a bit on both. Talking about both, here you have an example on how you harness heat from a binary power plant, just like as part of a cascaded scheme that Antoine was mentioning before. So basically, you would just like try to recover some heat on the cold end, on the end of a process. But in Belgium, I believe that these examples are probably more relevant. So basically, you have a well at certain depth, and then you just run it through a heat central unit, and then you have your application. Here in this case, space heating, could be something else, and then you re-inject, which is always the best case. I know that in Belgium you have cases where you have NORM, which is naturally occurring radioactive matters, and this calls for a closed loop on the geothermal resource. So you're not allowed to just have it open and do things that like we do in some other places. This is of course something that has to be taken into account on a case-by-case basis. Well, deep geothermal can happen in many different ways, and you have different temperatures. Just a reminder here, you have so many cases that operation and management is very different from one place to the other. In the case of direct use, so by direct use, we are talking about when we use the heat directly, like for space heating or other application like fish farming, horticulture, and other things, swimming pools and balneology. These are all the components that you have. So on the production case, you would have production well, reinjection well, resource gathering system, and reinjection, of course, and a lot of equipment. And you would transfer it to heat central, where you would also have a lot of equipment. And just think about it in terms of operation and management. Well, it's quite a lot of things here that are dealing with the geothermal system, and that you might experience various issues depending on the composition and nature of your resource. And then maybe more common, but I understand that in Belgium you don't have so many district heating systems, is the distribution to users and the operation and management, of course, and maintenance of a district heating system, which is more like classical, especially if you have two separate systems with a heat exchanger in between. Just a few examples we have here in Iceland, geothermal power plant up north, a very recent one, temperature very high, obviously, maybe not very relevant for you. Food processing, that's very interesting, and it's going to be the next best thing, I think, for geothermal around the world. Requires temperature typically around 80 to 150 degrees. Greenhouses, it's always very important for food security. Geothermal heating, here in the case of Reykjavik, where we use the waste heat from the geothermal district heating system to heat up the street and remove snow and ice, which is really good for the society, less people who break their leg or harm in bad weather condition. And of course, the example of Sinopec and Arctic Green in China. We started to help just to provide consultancy some 20 years ago, and it's just amazing to see the growth of these projects, and it's still growing. They have lower temperature, I believe, more like what you have or observe in Belgium. Okay, but I promised a few words about the development of projects. Usually it takes many years to start operation. You have like many steps to undertake. You have to know your resource, you have to plan and prepare, and when you implement, drilling is definitely a challenge. Even in your condition, you have to drill very deep and be sure where you're drilling, as sure as possible, based on the resource reconnaissance, and it's very complicated. Gives you time to plan for proper application of geothermal utilization. But after that, you have more than 20 years of operation, so you have to plan well. And just a reminder, you know, that it's very important. I'm going to give you a few examples of operation and management issue. This one here is in the Reykjanes Peninsula in Iceland. I think he had a pipe that burst and damaged some equipment there around that, so things can happen. But the first year of operation in geothermal, so this is probably in some cases more valid for some projects and for others, but you will have well decline, you might have enthalpy change, gas content change in some cases. Chemistry will just can be a challenging thing. I know that you have very salty water in Belgium, for instance. It's very challenging to use that. And then, of course, your team, your operation and management and maintenance team might not have all the skills or just know the system. I know that when we talk to operators here in Iceland, they have a very intimate knowledge on what happens when we do HAZOP studies on their system. That's just amazing, because they really know how the system is reacting to special events. So these are things that are quite challenging for companies who start operation, but then they just get up to speed. I wanted to mention here one case that's very typical for geothermal. Is just when you have a steam pipe that starts to leak, you will have corrosion that will start inside of a pipe. Bottom of a pipe is the best place. You have like a little bit of water sometimes, and then you could have cracks. It's just depends on how it's been fabricated and assembled, and you might have pipe stress episode and it will leak. It's a little bit challenging to deal with that. Another typical problem you have in geothermal project is scaling. It can be due to a high content of silica, calcium, and other components. And typically it depends on the design. It has to be properly designed, but it starts at the flashing point. What happens is that the diameter of the pipes is just reduced consequently quite a lot, as you can see on this picture and other pictures I have afterwards. And well, it's going to reduce the flow to a power plant or to a heat central, and it's going to be less power or heat that you will recover. But there are ways to deal with that, pipe cleaning and inhibitor systems and other systems. But it's challenging. Here is just an example. You can see the inside of the pipe. That's probably half of what it should be. Not really nice. Just a few examples, and then I will probably run out of time. And about operation and maintenance activities, some things are just like typical for just any power plant or heat central or district heating. You need people in place, and they just do basic maintenance activity. You will have access to the slides anyway afterwards. I won't extend on that one. When you will have routine maintenance, and that's also very typical. I expect you just have to make your plan for your plant. You would do also preventive maintenance. That's typical for any project or any power or district heating project, just to make sure that you prevent any breakdown ahead of time. And maybe what is more special for a geothermal project is planned maintenance stop. We do that in geothermal power plants, and I expect that we also do that in district heating, although to just a different extent. We have minor stops 1 week annually, and every 3 to 4 years, depending on the system, we just do a major stop. Here you have a turbine that has been taken out for overall, for just cleaning and maintenance. And you would just like take a look of that many pieces of equipment that could be under stress during operation. A few words, but then I'm done. It's the operation and the maintenance management. What we've seen in the projects where we are supporting developers is that some people just go to, we are going to do it ourselves. And then they need to have experience operation people, and then they need to train operators just so that they are up to speed on what's so special about geothermal. But they can also rent the services of other people, and that's the same for maintenance. Basically, you would have like contractors for major maintenance stuff, but you could also do everything with an external company knowledgeable. I'm going to stop here. Just to remind you, though, one last thing, is that, well, I know that in Iceland we're blessed with geothermal resources. It's a bit too much, maybe sometimes, like when you have a volcano eruption just a few kilometers from a geothermal power plant. I'm very glad that many things were put into place when we started to have the earthquakes a month ago. So it looks like we're able to protect to the extent possible all the utilities. But this project here is probably the highest geothermal project in the world, 3,500 meters above sea level in India. And they used geothermal to heat up a school. Just a very small, simple system so that it can be easily operated and maintained by the local population. So just do whatever you can with whatever you have. And for those who have geothermal under the feet, definitely that's a solution that's worth investigating. Thank you.
Thank you so much, Karina. And on behalf of our team here from the Energy Cluster in Iceland, we would thank you so much for giving us an opportunity to give you a insight in the expertise and the knowledge and experience my people and my members have. And they are definitely, as they already have mentioned, they're willing to take the steps forward. And having said that, I think that I will give the word over to Louise. And yeah, it has been a very impressive and interesting. Louise, thank you so much.
Thank you, Rosa, and thank you to all speakers. It was very interesting, and I think that now the members from our side have to digest all the presentations, because there was a lot of information. Nicola showed you that Wallonia has ambitious objectives regarding decarbonizing the heating sector, and based on your presentation, I think Wallonia is it's going in the right direction, because we are trying to set up an appropriate legal framework. Yeah, for example, there is a subsoil decree that has came up, and in order to protect and manage the resources, like Antoine told us. And regarding this point, I know that here in Wallonia there are some people that have questions regarding CO2 storage, because there are some regions in Wallonia that can be used for CO2 storage. But then what about geothermal resources? And maybe you have some answers or guidelines to provide us regarding this specific topic.
I would like to point this question out to Karin. Can you answer this question?
Yeah, you probably heard about the Carbfix experience. I think it's been an adventure. It started some 15 years ago. What has been achieved so far in Iceland with Carbfix is that we bind CO2. The idea at the beginning was actually a push from the legislation, because we wanted to reduce the amount of SO2, which is not really good for health, in the air. and we have a very strong regulation in Iceland. So we wanted to bind that and just like reinject that in the basalt layer. We also took CO2 with it, and it works definitely well because it turns into mineral within 2 years of starting. So you can just take a look at what Carfings has been doing. We've been helping them with the design. So we use the water that comes out of the power plant and just like make some kind of soda water, which we re-inject at some depth so that it just doesn't bubble up again and it just gets into the ground. Now Carfix is trying another, is having another project that has been financed by the European Union. And we are not going to use directly geothermal, but that's the same principle. They re-inject this solar water in the basalt layer. So if you have basalt layers, I guess that could be something that could be taken a look at. I know that they have been investigating other places around Europe, Turkey and other places. Yes, that's Carfix. That's definitely a very, very interesting case. If you come to Iceland next spring, definitely they will be here with us and present their showcase. That's a great thing.
Okay, thank you very much. Another question that I have, and I think it's because it's a problem in Wallonia. It's about the drilling capacity and also the skilled labor force. Did you face that problem as well in Iceland in order to support all the development of the geothermal projects?
I think I think it is overall a challenge to have the right labor skills. But maybe my colleagues can share their direct experience. Karine, do you have how we are managing this on our states? I think that there is a shortage already in almost every field, but maybe Karine, you can give us even more detailed information from your aspects.
Well, I don't have any figures. I know that as consultant, it's a big challenge, but Iceland is probably doing fine. And I must mention also that Iceland is doing a lot of things to attract both men and women into technical fields, which is very important because we need everyone. But it's been a challenge. We know it's a challenge for all countries around the world. So we have to make some noise about, that's very interesting. And I'm sure there are like kids today that can find a future job in geothermal.
That's maybe something which we can do together, the energy cluster and the cluster tree, to encourage the younger generation to deep dive into this field and see all the opportunities and how it is affecting and improving the societies where they would like to live.
Yeah, for sure. Yeah, we know that there is things to do regarding formation, definitely. I think we are running out of time, so what I will do is just share my screen just to show you an overview of the Walloon actors active in geothermal projects and district heating. Oh, sorry, there is something wrong. Wait. I will do it again. Sorry about that. No, it's not working. I don't know why. I will try last. Okay. This one. Okay, sorry, sorry for this. So you can have an overview of the Walloon actors. Of course, this mapping is not complete, but we know that it's really important to have an actor and a mapping of all actors, as well geothermal atlas, like Antoine told us. We are also working in that direction together with other actors like Risolia. So yes, like you said, Rosa, I think the both clusters, you and Cluster Tweed, try to promote all the geothermal projects and to ensure a certain transversality between the projects. And we try to promote to offer visibility and to connect actors from outside, from abroad. And regarding this point, and I will end with that slide. There is we have obtained some information regarding the Innovation Fund. So this is a fund from the European Commission, European Union, and there are 4 billion euros available to develop innovative projects. And one of the topic is focused on geothermal resources. So, and we know that Iceland is also eligible to participate to this program. So what we would do is we will publish those informations that are relevant for geothermal projects on our website and also on other platforms we are using to share information. And we hope that networking will happen and that some links will be done. So thank you very much, Rosa. I don't know I don't know if you want to give a conclusion word before we're leaving.
Just would like to say thank you all for participating on this webinar. I am convinced that this is only the first steps in this conversation progress we are building on, and I believe that we have way ahead of us really interesting opportunities. I would like to welcome specifically to our conference next spring, and I will communicate with Louise and her colleagues regarding specific opportunities for you and your group, and then you can learn even more. And together, I think that we can manage even better, moving faster and improving in a better way. And from that, I would like to wish you all a happy holiday ahead of us, and enjoy your time and think of your best one. Thank you all for being with us here today.
Thank you very much. Thank you to all speakers, and goodbye.